In this lesson, we're going to be solving systems of linear equations that are just going to be a little bit more difficult. And elimination is probably going to be the method of choice. So here's what we mean by that. So the first one, we're going to solve. And the first equation is not going to look difficult at all. That's not where the difficult problem comes in. You'll see as we go. So first equation is 6x minus 4y equals 12, and 3x plus 5y equals negative 6. So using elimination, we're always trying to cancel out a variable. And so we have to decide which do we want to cancel. Do we want to cancel the x's? Do we want to cancel the y's? If we want to cancel the x's, we can make that 3x into a 6x and make it a negative 6x, and that way we can cancel it. Or if we want to cancel the y values, we can make them both 20, and the signs are already taken care of. So it's totally a personal preference. So let's say we decide we're going to do the x's. And in order to cancel out a 6x, we can make this a negative 6x. So we'll distribute that through. And so that's going to get us a negative 6x minus 10y equals positive 12. Alright, so we distributed a negative 2 to all three pieces. We'll bring down the original equation. We haven't done anything with it. And we don't need to change anything anymore because we got our x's to cancel. And that's what we were shooting for. So we're ready to cancel. We're ready to combine our like terms. So this will combine and make a negative 14y equals 24. We'll divide both sides by negative 14. And this is where the difficulty comes from. 14 doesn't go into 24, so the best that we can do is reduce the fraction. So each of them are divisible by 2, so that will make a negative 12 sevenths. So the difficulty is, do you really want to take negative 12 sevenths, plug it into y, either equation, multiply it by a value, bring it over to this side, and then you got to get common denominators, you have to make this an improper fraction, and then you're going to have to divide that fraction by a 6. There's a lot more work that it takes because of the fraction. But, good news. We can absolutely restart the whole problem. We canceled x's, and when we canceled x's, that created our y, or got us our y. Start over. Cancel your y's to get your x's. So don't worry about the fact you have a fraction. We'll deal with that later on. Because the fraction didn't come until the very, very last step of dividing and reducing. So start over. So we'll take that 6x minus 4y equals 12. 3x plus 5y equals negative 6. And this time we're going to cancel our y values. When we do that, we're going to be left with our x values. So our y values, we can make both of them 20. And we don't have to worry about the signs. Signs are already a positive and a negative. So we'll distribute a 5 to that, and we'll distribute a 4 to that. So that'll get us a 30x minus 20y equals 60 for the first equation. 5 distributed in, 4 distributes into the second equation. That'll be a 12x plus 20y, our y's are going to cancel, equals negative 24. So y values cancel, just like we were shooting for. And we will combine our like terms. So this is going to make 42x equals 60 minus 24, should be 36. Divide by 42, and we're having the same problem as we had over here. 42 doesn't go into 36. So the best we can do is we can divide out a 2, we can divide out a 6. So if we divide out a 6 out of that, that'll be a 6 sevenths. So almost always when you have one of your values turns into a fraction, the other one's pretty much always going to be a fraction as well. And very often the denominators end up matching. So your check. If you're going to check this, one of two things. Either take your values, plug them in using a calculator, and see if they add up to 12. Plug them into this equation, see if it adds up to negative 6. Or you can do it by hand. Now doing it by hand, we're going to have to deal with common denominators, but it'll work out a little bit better than you think. So let's say we take the top one, and we'll just do the top one for now just to kind of show that it actually can work by hand. So it'll be 6 times 6/7 minus 4 times negative 12/7 is supposed to add up to 12. So to multiply this whole number times this fraction, we can really just put these whole numbers over 1. So top times top, bottom times bottom, and we'll get 36/7 minus a negative, so we'll be adding. 4 times 12 is 48. 1 times 7 is 7. We already have common denominators. That's great. So having common denominators allows us to add the numerators together. So 36 and 48 will make 84. And now we can reduce our fraction. 84 divided by 7 does add up to 12. And so then if we checked the other equation, we would do 3 times 6/7 plus 5 times negative 12/7, and it would work very similar to this, and you should also get a negative 6 out of it. So that's situation 1. If you get an answer that is a fraction, you don't have to plug that back in to get the other fraction. That is going to be a lot more work. Instead, start over, cancel the other variables. If you canceled x's first, cancel y's this time, and that'll get you your other value. Second situation, second type of problem that's a little bit more difficult is when your original equation starts off with a bunch of fractions. So if you have 1/5 x minus 1/10 y is supposed to equal 7 over 40. It's not ideal. And 1/4 x minus 1/5 y equals 11/40. Also not ideal. So first thing that we want to do, let's simplify this. Let's make this a lot easier. Instead of trying to cancel your x's and you're trying to get them to cancel, but you're also trying to find common denominators and making one positive, one negative, you don't have to do that at all. Anytime on any of these problems, we can 100% of the time clear out fractions. And clearing out fractions is essentially multiplying every single term, and they're totally separate. So this one and the second equation, you're going to potentially may do different math with each one. But you're going to try to figure out what will be a common denominator between all three terms. You have a 5, a 10, and a 40. Start with the biggest. Can the other ones become the biggest? Yes. So our greatest common factor for this is 40. We're going to distribute that in to every single piece, and that's going to create a new equation. So we take 40 times 1/5. It's basically 40 divided by 5 times 1 will be 8x minus 40 times 1/10 is 4y. 40 divided by 40 times 7 is 7. Second equation may or may not be the same common denominator as the first one. It's a totally separate equation. Start off with the biggest number. Can 4 and 5 both become 40? Yes. So we'll distribute 40 again. And if you notice, it clears out fractions. And then we start the process over. We don't worry about this anymore. We'll worry about this. So 1/4 of 40 is going to be 10. X minus 1/4 of, or 1/5 of 40 is 8y equals 11. Okay, we're pretty much done with the fractions until we get to the checking part. Otherwise, we start to work with this. What variable do we want to cancel? Looks like the y's are the easiest ones to cancel. So we're going to distribute a -2 in. We distribute a -2 because we want a +8 here to cancel with a -8. So we distribute this in. This gets us a -16x plus 8y equals -14. We didn't have to do anything to the second equation, so we'll just rewrite that, and we are ready to cancel. So our y's cancel, our x's combine and become a -6x equals -14 and 11 makes -3. Divide by -6, and we reduce our fraction and we get 1/2. Now, it doesn't mean that your answer won't be a fraction, which clearly we have a fraction as an answer, but at least the work doesn't have to deal with fractions until the very end. So once we have x, we'll pick one of these equations, or if you'd like, go back to the originals, but I think these are easier to work with. So maybe the top equation, we'll plug x back in. So we'll have 8 times 1/2 minus 4y is going to make 7. So 8 times 1/2 is 4, minus 4y equals 7. Subtract 4, subtract 4, negative 4y equals 3. Divide by negative 4, y equals negative 3/4. So we think our solution is 1/2 negative 3/4. Let's double check, and we'll just do this on 1. So we need to take this fraction, 1/2 and negative 3/4, plug them in, and let's see if we can make sure that it adds up to 7/40. So for our check, we have 1/5 times our x value of 1/2 minus 1/10 times our y value of negative 3/4 equals 7/40. All right, so 1/2 times 1/5, top times top, bottom times bottom, so that's 1/10 minus a negative will be a positive, and 1 times 3 is 3, 4 times 10 is 40. All right, the only way we can add these two together is to find a common denominator. And again, always start with the biggest one. Can the smaller value become the bigger value? Yes, it can. So we can multiply this by 4 to make it become 40. So whatever you do to the bottom, you're going to do to the top, because essentially you're multiplying by 1. If you multiply something by 1, it doesn't change it. We're changing the look, not the value. So 4 times 1 is 4. 4 times 10 is 40, plus 3/40 supposed to make 7/40. And now, since we have common denominators, our denominator does not change, and our numerators add together. Oops. So it checks. So we can do the same math for the second equation, and it should add up to 11/40. And that is our solution. So if we graph those two lines, they would intersect at 1/2 negative 3/4. And that is solving systems of linear equations by elimination, a little bit more difficult problems.